Good evening, everybody. Thank you very much for waiting. Sorry for the waits, because okay. So soon we are going to start our session. Okay. I'm not sure whether you have already been able to. Uh, I'm not sure whether you are able to. I'm not sure whether you are able to see this live right now. If yes, can you please at this response if you can hear me or not? Because sometimes I cannot really listen to myself while I'm talking to here. Okay, can you all hear me or not? Can you all hear me or not? Can okay. So now I have this. Wait, I have this answer. Have you ever received the answer already? So to those who not yet received your answer, I will now paste on the. I'll now paste on the comment right now for the answer in here. In case that you didn't get the answer yet. Okay, can you give me 1 minute? So that today you'll just be focusing on uh, answering the questions. Okay, okay. So this will be the apps. This will be the answer inside there, and it consists of all the slides that I wanted to share today. So you don't really have to copy. All you have to do is just focus, listen, and focus to what I'm going to talk about today. So yeah, good afternoon, everybody. Yeah? Okay, so as for the questions, I'm so sorry. Some of the questions that is not inside the some of the questions, the link that give the question is a little problem. I'm so sorry for that. However, you can download in any of the groups in there. Okay. All right. So without further ado, shall we begin our talks for this afternoon? I might not sound very well. If you cannot hear me properly, please don't hesitate to let me know because sometimes I cannot even listen to myself. All right. Okay. So are you ready? So without hesitation, let's begin, shall we? Okay, so welcome to the talks of answering technique for semester 2 and Mr. Chu. Thank you very much for your support. So shall we begin right now? Okay, so a little bit self-introductions. I'm Mr. Chu from this Johor, currently teaching in Tasik Utara. So this is my 20th years of teaching. Yeah, very this one already. Yeah, very old already lah. I've been teaching STPM Chemistry since 2009, 2003 until 2023. Yeah, so I didn't update the slide in here. Sorry for that. Okay. So a little bit of my information. So I was a national trainer previously for STPM Chemistry new syllabus. Unfortunately, I did not get to involve in the most latest syllabus since I'm not really into the MPM things anymore. So I just involve myself in another more sports already. Okay, so still I hope that my 20 years of experience will be able to help you to understand better on how to answer the STPM in here. Okay, okay. I was also examiner. I was also a national moderator for school-based assessment. I'm also a motivator and lecturer given talks about STPM chemistry and answering technique. I also wrote a few books. So most of you, if you're familiar with me, you should have already heard that I write this absolute guide for STPM chemistry, which can only be purchased through Shopee and no other platform other than Shopee. So yeah, okay. So this is it. All right. So this is the format of the scheme of assessment for STPM. So you have already sit for paper 1. So we are now in paper 2 already, which is term 2. So as usual, the format are the same. The format is the same. You have 15 section A, section B, section C, which are distributed in 15 mark, and 30 marks. Okay, and then last but not least, you have a school-based assessment, which is for this semester you are working on experiment 6 to 10, and then finally you have experiment 11 to 13, which is and then plus a project works in groups. Okay, so hopefully you all have already done the experiments already, right? Okay. Okay, so later I'm going to share a little bit with you on how to this one. Okay, so here are little tips that I would like to share with you before the examination for the remaining 1 week. Though it's a little bit too late, actually, for you to make sure that you have read in details of all the chapters in STPM Chemistry. So if possible, make our own short notes based on your understanding and check with your teacher reference books or online sources. So I've also already shared with a lot of your teachers. I believe your school teachers has already shared with you the short notes that I shared previously of the SEM 2. Of course, that short notes only cover like 60-70% of the whole things in semester 2, but it's good enough to help some students to pass if you manage to go through the short notes in a very detailed manner. Okay, so you should also do all the past year question. You have already, we have past year question from 2013 until 2022. We have a total of 20 sets of past year questions. So you must try your best to do all at least 10 sets. Okay, at least 10 sets. And then because, why I say like that, because if you look at 2022 SEM 2 ulangan, some of the questions has already been repeating for repeated 2013 SEM 2 ulangan question. So STPM is going to show some repeating trends already, right? Okay, so you should try to this one and answer. I've already shared the answer with your teachers and through various platform. Okay, through various platform, I've already shared the answer, so shouldn't be much of a problems for you to get the answer in there, right? Okay, so you should also do a study group with your friends. So actually, you learn and teach among your friends. For me, that is the best technique on how to study better. Okay. However, at this point, like I said, it's a little bit too late. So you should just try your best to do your best in anything you can. Right. Okay. So without further ado, let's continue with the prime objective of our lesson today, of our session today. So we are going to discuss all the 15 objective, 2 structure and 3 essay questions that I prepared for you. Of course, these are just the predictions of the questions. So it is not the real STPM questions, though it can help you to understand a lot of better things. All these are actually based on the past year questions analysis, and these are the examples of the chapters that I personally think that they will come out this year. So don't take it too seriously. That means, Mr. Chiu said structure essay come out chapter 2, chapter 7, chapter 3, chapter 4. Then I should only focus on that. Please do not think like that. If you really think like that, then you're going to have a lot of troubles later. So I still hope that you all will study accordingly in here. Okay. Okay. So this is the thing. Okay. So. Organization, shall we discuss the objective question first? Okay. Okay. So while I'm talking about how to solve the question, you can always stop me and then ask me any questions that you want. Okay. Okay. So let's begin, shall we? Okay, so question number 1 sounds like this. Experiment will perform to determine the enthalpy change of combustion for ethanol. So this is the experiment. The data collected are shown below. This is the mass of W. And then you have mass of ethanol burn is X. Temperature rise is Y. Molar mass of ethanol is Z. Specific capacity is 4.2 joule, Kelvin minus 1, gram minus 1. Actually, no matter is Kelvin minus 1 or degree Celsius minus 1, they are actually the same. Okay. Okay, question sounds like this. Which expression can be used to calculate the enthalpy combustion of ethanol in kilojoule per mole? Okay, so in here you have to use the 3 steps to help you lah. Either you use Q equals to MC delta T. By the way, when you answer structure and essay try your best to write your equation as Q equals to MC delta T. Teacher, can we write as Q equals to MC theta? Actually, following the latest information shared by other teachers who are currently marking, they actually says that the more proper one is Q equals to MC delta T. This is already stated in the what the it was stated already in the this excuse me. It was already stated in the it was already stated in our syllabus content. So that is why you are is already like that. Okay. Okay, so MC delta T. Then the second step is mole equals to mass over molar mass. And then number 3, you will find the Q and you find the mole, so you can calculate the Q. So in here, if we were to substitute in here, when we substitute directly when we say delta H is equals to, I'm using mouse to write my answer because my Q over more. Okay, so you have to substitute accordingly So Q equals to MC theta. Your mass of water is W. Okay, then your C is 4.2 Okay, and then your theta in here is temperature rise, which is Y. Okay, and then over your mole. So mole is equals to this mass over molar mass. So X over the molar mass of X, which is Z in here. Okay, so if you arrange accordingly, so you should get your RMM. You should get your answer is equals to what ABCD. Then over 1,000. And then don't forget that at the end of the day you have to over 1,000. So at the end of the day, what would you get for your answer in here? So this one straight away you combine, you put X at the top of here. So the best answer in here will be B. Okay. Sorry. Sorry. I think I already made answer. The answer is A. Sorry for that. Okay. Sorry. Sorry, I share. Sorry. Okay, so your answer in here will be A . Okay, so if you this one because eventually when you divide by this one you get WY over Z . Okay, these are all very mathematical things. Very mathematical things. So inside my answer scheme that I shows to you, I highlighted B in the answer, isn't it? Actually, the answer is A. I've already shows you the working, so I hope that you'll be able to answer. Okay, so this is for number 1. The answer is A. Okay. Okay. So any questions, Ken? Okay. So this is for number 1. So shall we go for number 2? Okay. Okay. So for number 2, combustion of the reaction of methane is described below. So enthalpy change of the standard formation of methane is the delta H1. So enthalpy change of the combustion. Actually, this enthalpy change of the combustion is actually equals to the formation of the CO2. Okay. And then this one, we will presume that it is the same with the enthalpy change of formation for water. Though in the real situations, actually combustion of the hydrogen will give gas. Okay. But in here, we just presume that it is enthalpy change of formation for water. So in here, we use total enthalpy change of the product minus total enthalpy change of the reactants. So you get the delta HF of CO2 plus 2 times delta HF of the H2O minus delta HF of CH4 plus 2O2. So in here, what is your answer? So if you look carefully, H2 stands for formation of the carbon dioxide. H3 stands for formation of water. So the best answer in here is donkey D lah. Okay. So this will how it represent the answer in here, right? Okay, so that is how you should answer for number 2. Okay. Okay, can understand so far? Hopefully no problem. Huh? Okay, so this is for number 2. Very straightforward. Okay, then you have number 3. The diagram show an incomplete energy profile for the reactions like this. Which reaction could be the diagram refers to? Now, if you understand carefully, this process shows the enthalpy change of the formation for endothermic process. Endothermic process. So the endothermic process hints it is the reaction that involve decomposition, bond energy, and electron affinity. Yeah? Okay. Can you give me like 1 minute? Sorry, I go and check out. Wait, I'll give you 1 minute and bring in the job right now. Sorry. Sorry, I got visitor. Wow, 1 minute only. Just go and bring. So sorry, got visitor. So sorry, got visitor. It's my ex-students. Okay, nothing. Okay, so let's continue back. Okay, let's continue. So this is an endothermic process. So the endothermic process include decomposition, which is a bond breaking process, and then the bond energy, which is in number 2, and then the electron affinity, second electron affinity, which is number 4. Okay, so in here, you should know by yourself that other than these few, what else could be also endothermic? So you should also try your best to remember some of the process that might be endothermics include this atomization, ionization energy. All right. So these are the other tools that are also endothermic process. Okay. So in this case, these are the 3 that might be this one. So the answer is C. Right. Okay. So this is for number 3. So any questions so far from number 1 to number 3? Okay, so that is for this one. Okay, so any questions for number 3? Hopefully no problem. Then we goes to number 4, shall we? Okay, so number 4, two half equations are shown. So you have MnO4 minus plus 2H2O plus 3 minus give MnO4 plus 4OH minus. So 2OH minus plus SO3 2 minus give SO4 2 minus plus H2O plus 3 minus. The equation between the reaction of manganese ion and sulfur ion are shown below. You have U, V, W, X, Y, Z as shown in here. Which statement is correct? So U is equals to Z is equals to X in here. Okay, so is it correct? So in order to balance this equation, so you must be able to write the this one. So everything inside this equation must be multiplied by 2, and everything inside this equation must be multiplied by 3. Right? So in here you should have 2 MnO4. So this one will become 4 H2O. This one will become 6 electron. This one will become 2 MnO4. This one will become 8 OH minus, isn't it? Okay. Then this one will become 6 OH minus. This one will become 3 SO3. This one will become 3 SO4. This one will become 3 water. This one will become 6. Okay. So you can start to cancel already. 6 electron definitely must be cancelled with 6 electron. So 6 hydroxide cancel with 8 hydroxide. You have 2 hydroxide left. Okay. And then you have 4 water cancel with 3 water. So you have 1 water left, isn't it? So what is your overall equation at the end of the day? So after the balancing the whole equation, you get 2 MnO4 minus plus H2O plus 3 SO3 2 minus, give 2 MnO2 plus 2 OH minus plus this one. So your U, X, and also Z. Okay. Oh, Z is OH. Okay, number 1 is correct. Yeah. I accidentally copy paste wrongly. So number 1 is correct. Number 1 is correct. Okay. Number 1 is correct in this case. Okay. Then number 2, manganese ion is reduced from +4 to become +6. Is it correct? It is also correct. Yes, it is also correct. Okay. And last but not least, number 3. Okay, so number 3, this changes of oxidation state in here will be equals to this one. So pardon me for a while. Okay. So in here, your okay, so in after balancing the whole equation, so your U and X and Z are the same, isn't it? 2 and 2 and 2. So 1 is correct. So number 2, manganese ion has become sulfate. So number 2, changes of oxidation state of Mn to MnO2 is from +7 to +4. So B also correct. And then changes of oxidation state from SO3 is from +4 to +6, which is also correct. So in this case, all 1, 2, 3 are correct. So the answer is A. So in here, the answer is A. So I'm so sorry, I put my answer as D because I mistakenly copy paste the wrong thing. So as you can see in here, that all number 1 and number 2 and number 3 is also correct. So the best answer for number 4 is A. The number 4 is A. Okay. Okay. Thank you. Sorry for the corrections. So I've already corrected in the slide right now. So can you please help me? Number 4 is A. Okay. Okay. So that is for number 4. Okay. 3 is also correct. Yes. All 1, 2, 3 correct. Yes. All 1, 2, 3 correct. So the answer is A. Okay. All 1, 2, 3 correct. So the answer is A. The changes is from +4 to +6. Yes. Okay. Okay. So that is for number 4. Okay. Okay. Then we goes to the next one, number 5. when copper is extracted from its ore, the metal is not pure enough for the electrical uses. The impure copper, which contains small amount of silver and gold, is purified by electrolysis. During this process, a sludge that is beneath the anode could be found in the silver end with a trace of gold. Why silver is found as the end? So as you can see inside the diagram in here, okay, you notice that there is a small sludge of the etched in here in the impure anode. So why is there a small sludge of the impure anode? So usually this small sludge consists of impurity that are less electropositive than copper, such as silver, gold, and also platinum. Okay, so the answer in here is due to silver is less electropositive than copper, so that is why they were left as a sludge in there. Okay, so that is why is it that there is this one. Okay, never mind. Thank you very much for helping me to correct them. Because sometimes you when you are chatting, I can also see here. So this one. Okay, so no problem. Okay, so that is for number 5. All right. So number 5 is A. Okay, then we goes to number 6, shall we? Okay. Okay, number 6. The EMF of the following cell under the standard condition is 2.46. You have AL, 3 plus, double line, AG plus, AG. So students, you should be very familiarized with the how to write the cell diagram, how to write the cell diagram in here. So hopefully you'll be able to learn on how to write the cell diagram correctly. Everything at the left side is for oxidation. Everything at the right side is for reductions. Okay. Okay, so which statement is true about the cell? So as you can see, Al3 plus is not the cathode, it is the anode. Okay, and then Ag act as the oxidizing agent, which is wrong. Ag plus is the one that act as a oxidizing agent. I type as reducing. Sorry, it's supposed to be oxidizing. It is the Ag plus that act as an oxidizing agent. Okay, it is the Ag plus that act as a oxidizing, not Ag. Ag is not oxidizing agent. It is the Ag plus. So B is also wrong. Okay, and then C, the standard reduction potential of the Al3 plus, is it positive 1.66? So you use E cell equals to E cathode minus E anode. So 2.46 equals to positive 0.8 minus E anode. So it's negative 1.66, not positive. Okay, and then finally, the dissolved mass of the aluminium is 1/12 times compared to the production of the mass of silver. So in here, you use the Faraday's second law, you calculate the mole of silver. So because we don't know what is the mass of silver, I'm going to put an unknown A. So mole of silver is equals to A over 108, which is the RAM of silver. So since Ag plus E minus give Ag, so mole of electron is equals also to A over 1800. So as Al3 plus 3 minus give Al, so mole of aluminium is 1/3 times A over 108 is A over, not A times. It's A over, not A times. Sorry for that. A over 108. So therefore, mole of aluminium is equals to A divided by 3. Okay, times 108 multiplied by 27. So sorry lah. It's supposed to be 1/3 times what? A over 108 lah. It's supposed to be like this. Okay. Then this is the mole of the silver, then multiply by 27, which is the this one. So you cancel this one, you cancel this one, you get 9. Okay, so cancel this one, you get this what 27. So you got A over 12 lah. Okay. Sir, in SRP table, A is negative. We don't reverse it. If you use E cathode minus E anode, we never reverse the standard electrode potential. Okay. When you use E cathode minus E anode, we shouldn't reverse the electrode potential. Okay. Okay. So don't reverse the electrode potential. Okay. So as a result, this one is 12 lah. Okay. Okay, so that's why A over 12, so the answer is donkey D. Okay. If you use E cathode minus E anode, the E anode itself will become the value of the standard reduction potential. So it is not the positive, sorry. So hope that you don't misunderstand about this concept. Okay. Okay, so that is for number 6. Okay. Any questions so far from number 1 until number 6? Always remember, if you use E naught cell equals to E naught cathode minus E naught anode, don't reverse the equation. Don't need to reverse the equation. You straight away use the standard electrode potential value from this one. If you want to use the Hess law-like method, then you use it like Hess law-like methods. Understand? But in this case, if you want to calculate the E naught cathode or E naught anode, it is wise for you to it is wise for you to use the this E cathode minus E anode. Okay. Okay, so that is for number 1 until number 6. So hopefully you all can still understand on how to solve this. Okay, so without further ado, we continue to number 7. Okay, in 1999, researchers works in the USA believed that they had made a new element and they has the following electronic configuration. Rn stands for radon. F5, F14, 6D10, 7S2, 7P6. So our main focus will be the valence electronic configuration 7S2, 7P6. So if it is 7S2 and 7P6, which group does it belongs to? So it belongs to group 18 in this case. Okay, so the answer is donkey D. Okay, so that is for number 7. So very, very straightforward questions in here. All right. Okay, so that is for question number 7. Okay. Then we straight away continue number 8. Highest oxidations of element from chlorine, sodium to chlorine are separately added to water. Which diagram best represent the pH value of the resulting mixture in here? Okay, so in here, what is the best graph that represents the value? So you must know what is the resulting pH value. This one. So number 3, why is 4 correct? Number 3, why is 4 correct? Oh, correct. Why not? Oh, correct. Second electron affinity. Second electron affinity. Second electron affinity is endothermic process. Okay. Okay. So back to this one. So you have to understand the nature of the question. So in aqueous solutions of the oxide form, so Na2O when dissolved in water, you form NaOH, which is a strong base. MgO is a weak base that forms somewhere in between 8 to 10. All right. And then aluminium oxide and silicon dioxide. Aluminium oxide and silicon dioxide are insoluble in water, so we cannot actually determine the pH. But for your information, SiO2 and CO2 is this one. Okay, but we are going to focus on next one. P4O10, when dissolved in water, you form weak acid. H3PO4 is weak acid for your information. And then when SO2, SO3 dissolved in water, you form this sulfuric acid, but actually HClO4 is a stronger acid. So that is why the graph that best represent the whole thing is this one. So the answer in here is A. Okay. Okay, so that is how you are going to answer for question number 8 in here. So the best answer for the graph is A. Okay. Thank you very much for helping me to explain. Thank you very much. Sometimes I cannot really take care of everything, so I need your help. If you are able to help me to explain to your friends, so please help me to explain to them. Okay. Okay. So that is for number 8. Okay. So if no problem, then we goes to continue to question number 9, shall we? Okay. So number 9 sounds like this. When magnesium or its compound loses, which magnesium or its compound loses its max when heated with a Bunsen flame? So magnesium, when burned, will form magnesium oxide. So when you form magnesium oxide, it increases its mass, not lost its mass. Okay. Okay, and then magnesium nitrate, yes, will lose its mass to become magnesium oxide, nitrogen dioxide, and oxygen, because NO2 and O2 are gases, so it will lose its mass. So B is correct. MgO, magnesium oxide, will not further oxidize. That is why the mass does not change. And then magnesium sulfate. Now, actually, magnesium sulfate can decompose, but at a very high temperature. So Bunsen burner cannot be able to achieve that. Okay, so the best answer in here is boy B. Okay, so that is how you are going to answer for question number 9. Okay, so the keyword in here is the Bunsen flame. Okay, all right, so that is for number 9. Okay, so if no problem, any questions so far? Number 7 to number 9. Okay, so if no problem, then we goes to number 10, shall we? Okay, the graph represents the variations of the properties of group 2 element. What is the properties of this? So you should understand some of the physical and chemical properties of the group 2 in here. So as going down to the group 2, your ionic radius increased, so that's why A is wrong. Ionization energy decreased, so B is correct. So neutron over proton ratio. What is neutron over proton ratio? If you look carefully, for example, beryllium, nucleon number is for beryllium is 9, if I'm not mistaken. Over proton is 4. Okay. Magnesium is 24 over 12. Okay. Never mind. Okay. And then calcium is 40 over 20. 40 over 20, and then calcium is 40.1 actually. Strontium is how many? I forgot already. I didn't have a periodic table with me, so can you please help me to check the atomic mass in here? I didn't have, but the nucleon over proton ratio is increasing. Okay, so this one 238 minus 237 minus 92 is 140. 43 over 92. Okay, so you find out that their ratio is actually increasing, also can. And then this rate of reaction when going down to the water also increase in here. Okay, okay, so in here the best answer is point B. Okay, all right, so that is how we are going to answer for number 10. Okay. This one is wait. This one is not 24, it's 12.3 12. It's actually 12 because we are talking about neutron. So this one is also 20. Okay. This one is not 4, this one is 5. Okay. Sir, may I ask which MB has a better electrical conductivity? We look at the electrical conductivity based on the this one. Wait, let's go back to you. Teacher, may I ask beryllium and magnesium, which one has a better electrical conductivity? Electrical conductivity is based on the metallic bond strength. So in here, I would say that beryllium has a greater electrical conductivity. You can also search online through Google's that you type electrical conductivity of beryllium, then you type electrical conductivity of the magnesium. So you realize that beryllium has a better electrical conductivity compared to magnesium. So do you mind do a little Google on this one? Okay, so the what I can say in here is the electrical conductivity is based on the metallic bond strengths in here. Okay. Okay. So any else questions? Okay. So okay. Thank you very much for this one. Welcome. Okay, then we goes to the 11. Group 14 elements, carbon, silicon, germanium, all exist in a diamond structure. The bond length in between the structure are given below. So why does the bond length increase down to the group? Bond length increase down to the group. Oh no, here I made a little mistake already. Okay, so the bond length increase down to the group is due to so as going down to the group, so the atomic radius increase. So when the atomic radius increase, so when the atomic radius increase, okay, so it will result the bond length to increase. So the answer is actually B. So the bond strength is the result of the bond length increase. Okay, so the best answer for these questions, the best answer for these questions is boy B. Okay, what does the bond length? Why does the bond length increase? Is due to atomic radius increase. The final answer D, bond strength decrease is the result of the increasing bond length. Okay, so the best answer for number 12 in here is boy B. Okay, so help me to correct that. Inside my slide, I put as D. I apologize for that. So do you mind helping me to put boy as your answer? Okay, number 12. Yeah, thank you very much. Okay, so now when you study physical properties, especially for group 14, you should try your best to remember what reason is used to explain what purpose. If you are trying to look at the reasoning of the atomic radius, ionic radius, you should look into nuclear charge screening effect, then effective nuclear charge, right? Concluded by effective nuclear charge. And then if you are looking at this, if you are looking at the melting point, boiling point, you have to look at their structure, whether it is a metallic bond, giant covalent structure, simple covalent molecule. Okay, then you explain based on that. If it is ionization energy, generally, we say it's ionization energy increase. What are the factors that influence them? Atomic radius, nuclear charge screening effect. However, if you are comparing ionization energy from the same period, let's say you are comparing in between group 2 to group 13, group 15 to group 16, then you use their valence electron to explain. And finally, when you are about to compare their electrical conductivity, so when you are comparing their electrical conductivity, is this one, okay. Yeah. Teacher, SnCl2, SnCl4 more stable. As in a case of tin, SnCl2 more stable. Okay. SnCl2 more stable. Thank you very much for helping me to answer. Okay, thank you very much. Okay, so number 11, the answer is boy B. Help me to correct inside the answer scheme. I highlight wrongly. Okay, number 12. Solid carbon dioxide is similar to the solid iodine in structure and the properties. Carbon is the group 14. Carbon is in group 14. Silica, SiO2 is a group 14 compound. Which statement about carbon solid and SiO2 is correct? Okay, both exist as a lattice structure. In here, CO2 arranged in an orderly manner, 3D crystalline structure, while SiO2 is amorphous solid arranged in orderly arranged manner lah, unorderly arranged manner. Okay, so that is the difference. Okay, and then CO2 is a simple covalent molecule held by weak van der Waals forces, while SiO2 is a giant covalent structure. And then SiO2 are held by single covalent bond, while CO2, it is still possible for the CO2 to form the resonance structure with a single covalent bond, but it is not stable. Even though we say that it is not stable, still that it is a possibility to form. Okay, and then finally, CO2 is a gas under room temperature pressure, while SiO2 is a solid under room temperature pressure. So inside here, I'm going to give the answer as C lah. Some of you might not agree with me. You might say that the answer is A because both solid exist as a lattice structure, but because usually when we say lattice, it has an orderly arranged manner. It has an orderly arranged manner. Okay, so this objective is a little bit difficult, and I'm so sorry for that because I said in such a way that it is a little bit difficult. But that is how we should answer this. Okay, okay. Teacher, does Sn also have inert pair? No, inert pair is only apply for lead only. Teacher, in exam can write both solid in simple covalent molecule during answering essay. No. Because this CO2 is a simple covalent molecule, while SiO2 is a giant covalent structure. They are totally two different. This one, okay, cannot. Cannot. You don't give wrong statement. That is what I try to say at the end of the day. You don't give wrong statement, so cannot say that both solid simple covalent molecule. Okay. Okay, so that is number 12. Okay, so the answer is A in here. Okay, the answer is C, sorry. The answer is C for number 12, right? Okay, then 13. Which is the complete list of all the product of the reaction if concentrated sulfuric acid react with potassium bromide? So you have to understand what are the equations that react when it react with the potassium bromide. You form a potassium hydrogen sulfate with HBr, then the HBr will further react with H2SO4 to form a Br2 plus SO2 plus 2H2O. So what is the best answer? A, B, C, D. So the best answer in here is donkey D. Potassium hydrogen sulfate, hydrogen bromide, bromine water, and sulfur dioxide. Okay. So that is for number 13 in here. So that is for number 13. Okay. Okay, any questions so far? Now, if you notice carefully, most of my explanations of, especially when involve chemical equations, they will involve this state of matter, isn't it? So actually, in my opinion, in following the latest way of how my friends share with me, nowadays the chief examiner requires students to write state of matter already for semester 2. Okay, so try your best to write the state of matter for inorganic chemistry too lah. So if write wrongly, it depends on teacher lah. Some teacher might accept, but some teacher might not. Okay, so I don't know what is going on inside there. So I can just advise you all based on what I heard from the chief exam, from my friends. That is this one. Okay. Okay, so that is what I can. That's what I can say in here. So, is it necessary to write molarity when write in the cell diagram or not? What does it mean necessary to write the molarity when write in cell diagram or not? No need lah. Usually the molarity is fixed. For standard condition is 1.0 mole per decimeter cube. So if the this one you don't need to write molarity unless it is not standard. It is not standard, then you must write molarity. But usually no lah. STPM usually will not ask you to write unstandard lah. they will only give to you, but they don't expect you to write. Okay. Okay. This is what shown just now. Okay. No need to write molarity. Okay. Then we go to number 14. That's what I say just now. That's what I say just now. You have to write state of matter nowadays. You have to write state of matter nowadays. The chief examiners insist students must write state of matter. So I know it's very challenging for the students to write the state of matter. Last time they don't bother, but nowadays maybe because we have a new, not to say new chief examiner lah. The chief examiner have been promoted, so that's why physical state must be written. Okay. Okay. So which indicates the relative strength of hydrogen bond. So hydrogen bond in HF usually apply in explaining the boiling point or enthalpy change of vaporizations. So that is why the best answer in here is donkey D. When do we discuss bond dissociation energy? So bond dissociation energy has to do with the thermal stability of the HF. So that is why when going down to group 17, the stability of the HX decrease down to the group because of the atomic radius increase. So for formation and solution, more or less goes to be the same. Okay. Okay, so that is for number 14. So very, very direct questions for number 14. Okay, and last but not least, cobalt can form the positive ion CONH3 4Cl2. What is the oxidation number and coordination number of the cobalt ion? So in here, you calculate so CO plus 4NH3 plus 2Cl equals to plus 1. So CO plus 4 times 0 plus 2 times minus 1 equals to plus 1. So CO is equals to plus 3. So the oxidation state of cobalt is plus 3. And since there are 6 ligands, therefore a coordination number is equals to 6. So the answer in here is D. Okay. Okay, so for group for objective, that is all. Okay, I can see what the question. Isn't SnCl4 more stable? No. SnCl2 more stable. It is the SnO2 more stable. SnO2 is more stable as plus 4, but SnCl2 is more stable as plus 2. Now you don't ask me why is it like that. I don't know. Okay. Okay, so with that, that is all for the objective question for number 1 until number 15. Okay, so any questions so far? Which part in here that you can understand or like me to repeat for you? Okay, so I guess until here, you all have no questions so far. So if no questions, can we go on to the next one? We are going to go to structure questions. So you mean the state of mass? So you mean that the state of matter is important? Yes. So is hexadentate stronger? Yes, guarantee. Okay. So maybe SnCl4 is a covalent compound where SnCl2 is an ionic. That's why I said I'm not sure. I cannot say that for sure. Probably one of the reasons. Probably. But sometimes doesn't mean that. It depends on a lot of factors actually. So I cannot say that for sure that it is due to SnCl4 is compounds, SnCl2 is ionic. I cannot say that for sure. I don't know. Things that I don't know, I dare not answer. Okay. Okay, can Okay, so that is all for the 15 objective questions. So never mind, as we pass, as the time pass by, you'll be able to answer accordingly. So let's continue to the next one, shall we? Okay, so section B, answer all questions. So you also advised to spend 50 to 20 minutes to answering this session. So answers should be short and clear and do not over focus in one question. In structured questions, if you know, then you know. If you don't know, then you won't know. It's a no or don't know questions. Okay. Okay, so back to where we from. Okay, so that is for structure. So we begin for the structure questions. Okay, for structure question, I'm so sorry lah. Supposedly question number 16, I should apply some of the thermochemical. Some of the question I should include the standard electrode potential value. Students are not really expected to memorize all these ionic equations. So that's why supposedly you are shown the standard electrode potential value. I apologize for that. Okay, because I'm too used to the data booklet that sometimes some of you have some of the teachers, they share the data booklet with you, isn't it? So you just refer to that data booklet. But nowadays in STPM question, they don't really have that data booklet anymore. Any questions that when they wanted to ask you based on that, they will straight away ask you based on that. Okay, chloralkali cell is among the most common electrolytic cell used widely in industry to manufacture chlorine due to its advantages to produce many useful side products at the same time. So diagram below shows the common setup of chloralkali cell used in industry. Brine is used as electrolyte in the compartment, in the anode compartment, while water is filled at the cathode compartment. So let's have a look at the questions. A, what is the major constituent in brine? Either you write concentrated or saturated sodium chloride. Okay, the word concentrated is this one. So if I just write sodium chloride without concentrated, okay or not? Advisably write concentrated. Advisably. Yes. Why not? Why not? The answer is correct. Concentrated sodium chloride is correct. Okay. No. Strictly must be sodium chloride. Brine is sodium chloride. Okay. Brine is majorly sodium chloride. So must write strictly on this one. Okay. So I'm going to accept this one. I'm also going to accept this one. I'm not going to accept this one. Cannot write concentrated salt. Cannot. Okay. Okay. So that is for 16. Okay. Then 17. State the material used in anode cathode in the cell above. So what is used as the anode and cathode? So anode is titanium, cathode is steel. This one must memorize a bit. This one must memorize a bit. So you must be able to write down what is used for it. And then C, write the half equation occur at anode, cathode respectively. So at anode, this is the half equation. State of matter is right. So if I write NaCl only, I advisably write concentrated NaCl. Advisably write concentrated NaCl. Advisably. Okay. So write the half equation occur at anode and cathode. So try your best to write the state of matter 2Cl minus aqueous give Cl2 plus 2A minus 2H2O plus 2A minus give 2OH minus plus H2. Okay, so that is the half equation at anode and cathode respectively. Okay, D. Asbestos is used as a diaphragm to separate between electrolyte in the anode and cathode compartment. State the advantages of using asbestos as the material to separate between brine and water, because asbestos can use to attract or absorb only cation and allows to penetrate through the cathode compartment. So asbestos is actually used as an ion exchange. So that's why we can say that it absorbs the cation. Okay. So that is the advantages why we use asbestos, okay? Because it absorbs the cations in here. Okay. Okay, so asbestos is the example of silicate used in daily life. State the type of silicate in asbestos. So it's amphibole, amphibole. Hello, sir. May I know is it compulsory? Yes. I already told you state of matter is a must. Okay, state of matter is a must. Can I write prevent Cl react with NaOH? Cannot. It is not for that purpose. What is the electrode used for anode cathode? Anode platinum, cathode steel. Cannot. You get mark for steel, but you won't get the mark for anode. Anode is strictly titanium. Okay, so what else? So there's a question that explains our answer in terms of structure bonding. SL2 can we simple covalent molecule, simple covalent structure, same. Asbestos only allow ion to flow between the compartment, cation, because you cannot say ion. Try to say cation because it attract only the cation. Okay. Amphibole as double chain silicate. Double chain silicate is the characteristic, not the type of silicate. It's the characteristic. So I doubt that they will accept that. Graphite cannot be used as anode. Cannot. Strictly must be steel and titanium. Strictly steel and titanium. Other than this answer, we cannot accept. Strictly. Okay. Strictly these two answer. Other than these two, we cannot accept. So electrodes are same for diaphragm cell and mercury cell. Different. Okay, different. Diaphragm cell is another. Mercury cathode cell is another story already. It's not inside here. Our STPM focus more on the diaphragm cell already, not mercury cathode cell. No more. Okay, Ken. So that is for number 16. Why I purposely pull out this question? This question was asked 2 times already, 2013 SEM 2 and 2018 or 19, I forgot already. So just in case, furthermore, I just pull out to ask various questions in there. Okay. Okay, so that is for this one. Okay, Ken. Okay. Any else questions? Can Okay, so no problem. Then we go to 17. Copper is a transition element that form complex with oxidation state +1 and +2. What does it mean by terms transition ion? I didn't write the answer. So sorry. Okay. Can I put in the answer now? Sorry, I didn't notice that I didn't put the answer in here. So can you allow me to put in the answer right now? So you are going to write as the this ones. Can you give me like 1 minute? 1 minute. So what else questions that you wanted to ask in here? Okay. So transition element, one more stable ion. Yes, correct. Okay, correct. Element that can form more. Yes, correct. Your definition are all correct. Okay. Sir, what determine the transition metal of how many coordinate bond? Actually, this one, to be honest, I do not have an absolute answer to state what determine transition metals can form how many coordinate bond, because one transition element, they can have various coordination number. You can form 2, you can form 4, you can form 6, no problem. So what is the factors or what determine, to be honest, I don't know how to explain this. Okay, so I can only say that I don't know, because I really don't know how to determine based on the transition element alone. There are a lot of factors that determine this, okay, including steric hindrance. So this system can be said because it's porous. No, cannot. It's not porous. It's not because of porous. It's why we use the diaphragm. We only want the sodium to penetrate through the compartment. Okay. Okay, so that is 17A. Okay, very good. All of most of you are this one. Okay, now this one is dangerous. Transition element is that form one or more than stable ion. More than one stable ion. Be careful. Be careful of how you write your words. Okay. Okay, very good. Most of you are able to get it. Okay, so name the complex below. When it comes to this complex, I know some of you are going, okay, so Cu NH342 plus is tetraamine copper 2 ion, whereas CuEDTA is ethylene diamine tetraacetato cuprate 2 ions. Naming this CuEDTA, teacher, is it compulsory for us to know? It was asked in 2013 Sem 2 Ulangan last time. So yeah, you have to know on how to name this, okay? Okay, so that is for number 1. Okay, number 2, arrange the stability of the complex ion in descending order. So take notes of the words, descending order. Okay, so that means from the most stable to the least stable. So CuEDTA, CuNH342 plus, and CuCl42 minus. Okay. Okay, so in here, sometimes STPM, because they want to cover some difficult marks answer, they will give more than 1 marks in here. Okay, so you have to mention that EDTA is a hexadentate ligand. Okay, teacher, can we say polydentate? Cannot, strictly must be hexadentate. Okay, hexadentate ligand. Hence form chelating effect with copper 2 plus. Okay, hexadentate ligand is the keyword. Chelating effect, if you write, very good. If you don't write, I don't think it doesn't really matter here. But chelating effect is an important effect. So try your best to remember. Okay. In this, so when naming the complex ion, must write ion at the end of the complex. In this case, there are ion. So ion is a must. Write ion if have charge. Yes, thank you very much. Chelating agent can, replacing the chelating effect. No. Chelating agent. Okay, can. Chelating agent can. Chelating agent can. Chelating agent can. Can we use this one? Mathematical sign is not important. We don't really look at mathematical sign. Okay, we don't really look at mathematical sign. Okay. So can write EDTA is a hexadentate ligand that forms 6 dative bond. Keyword is hexadentate ligand. Keyword is hexadentate. So what is chelating effect? I forget already. Chelating effect is an effect where it is the word chelating effect is used to explain how a polydentate ligand gaps the center metal ion, hold the center metal ion stably, like many claw, you hold to an object like this. So this is chelating effect. Okay. Okay. Whereas both NH3 and Cl minus are monodentate ligands, so NH3 is a stronger ligand than Cl minus. Okay, keyword NH3 is a stronger ligand than Cl minus, so that is why you can displace them. Okay, but if I were a student, I would definitely write their category, whether they are this monodentate ligand, bidentate ligand, and accordingly. Okay. Okay, C. CuCl42 minus is yellow solution, while CuCl43 minus, however, is colorless solution. Explain why CuCl43 minus is colorless. So try your best to answer. So CuCl43 minus oxidation state is +1. Hence, copper electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. So teacher, can I write the valence electron is 3d10? Because the question does not specifically say that whether you should write electronic configuration or valence electronic configurations. So I figure out that both of them are accepted. Can, no problem. So since 3D orbital is complete field, when you answer this, try the keyword in here. DD electronic transition does not occur. The word electronic must be there. The word electronic must be there. DD electronic transition. So try to write the word DD electronic transition. Okay. Okay. So that is for this one. Huh? Okay, so that is for number 17. Okay, any else question that you want to ask in regards of this? I have a very strong feeling that transition element will come out for this STPM. Last year didn't ask at all. 2022, 2022, ulangan don't come out. You are lucky enough if they come out in essay, so you can skip them. So I just worry that they will come out in structure like this one. So you have to, by hook or by crook, this one. Teacher, can I write normal gas electronic configuration? For what? For what? What do you mean by this? Can write normal gas electronic configuration? I do not understand. So I thought negative ligand are stronger ligand than neutral ligand. So Cl minus. No, 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 no. No, not like that. Please, this one. Can we use in essay? You can use. I never said that you cannot, but the order is more important than the sign. The order is more important than the sign. Okay. Oh, AR 3D10. Keyword is 3D10, but try to avoid using bracket AR. Try to avoid using bracket AR. We don't accept bracket AR in STPM. No. Okay. Teacher, how do we determine the strength? Now for the strength of ligand, can you Google this? I think Google will show you in here. I Google for you right now if strength of ligand. I think if you Google it, they will give you what is the order of strength of ligand. There are many, you can refer there. Yes, I just Google for you. Okay. Okay, teacher can write electronic configuration. Can. No problem. No need to write 4S0 lah. No need to write 4S0. Just write 3D10 enough. In this case, can. No problem. Because the question do not specifically say that it must be valence electron or electronic configuration. So both of them are accepted. Okay. So Cu plus has complete 3D orbital. So no DD transition. Can. In this case, can. You already explained because complete field. However, I can only give you 1 mark for this. Must write DD electronic transitions. Electronic transition. The words electronic must be there. Okay. Welcome. Okay, so I hope that this will help you a little bit in understanding the context in here. Okay, Ken? Okay, so any else questions? Yeah, so if no problem, then we go on to the next one, shall we? Okay, so we are finishing the structure. We are going to go for essay question. So in here, you only have to answer 2 essay questions. So students, you should advise to spend 20 to 25 minutes per essay question in this section. So do your best to present in essay full with contented relate to the question. Point form, table form is about, but not advisable unless you are really confident. If possible, try to use essay form. Try to avoid point form. Unless you are really confident that that is the point that you want to express, then go ahead. Okay. But as I said, if possible, try to write in essay. Okay. Okay, so here comes the question. Radium is a group 2 element. Experimental lattice energy of the radium sulfide RAS is negative 2612 kilojoule per mole. So chelating effect is enough already. Chelating effect okay already. Okay, lattice energy is the energy released or liberated when 1 mole of solid ionic crystal lattice is formed from oppositely charged ion under standard condition. So 1 mark for writing the energy liberated or released when 1 mole of solid ionic crystal lattice is formed from oppositely charged gaseous ion, 1 mark. Under standard condition, 1 marks in here. Okay, so very, very straightforward. Huh? Okay, so that is for 18A. Then 18B, some data relating to the radium and sulfur are listed. Selected relevant data is used to answer to part B to part C lah, actually not E lah, C typing error. Okay, so these are the relevant data given. So construct a Born-Haber cycle for the RAS solid, hence calculate the enthalpy change of the formation for the RAS and estimate the value of the lattice energy for calcium sulfide based on the value. So explain your answer in here. Okay. So you should write your y-axis as the enthalpy in kilojoule. I checked with many references already. Try to avoid using energy. Is enthalpy. Okay, enthalpy in kilojoule. Okay, and then when you write, so and then in here you should try your best to put 0 in here. Can you please? Okay, can you please put 0 in here? Okay, so try your best to put 0 in here lah. So you label lah one by one what is the process that take place because you are constructing for Born-Haber cycle. So I would usually advise students to write one by one what does each of the stage represents in here. Okay, so that is how you are going to construct a Born-Haber cycle. Okay, so try your best lah. Must this one. Teacher, can in the first electron affinity, second electron affinity, you can write combine like that. Can we separately write like, because first electron affinity is exo, second electron affinity is endo. So this one. Okay, wait. If we write the heat energy released when 1 mole of ionic solid is formed. Ionic solid is formed. Actually, it's crystal. It's a crystal. Crystal ionic lattice. Crystal is a very important word. Okay, crystal is an important word. Okay, because it's trying to show that it is a orderly arranged 3-dimensional solid. Okay, so can write 1/8 as 8 or not? Can. The question right, give 1/8 as 8. In fact, you should write 1/8 as 8. Yes. Later I correct it inside my slide. If question asks draw Hess cycle, should we? No lah, usually Born-Haber cycle is Born-Haber cycle very, very directly. So teacher, no need to write the value of delta H. Can represent by delta H, can, no problem. Can represent the value, can, no problem. Can use the enthalpy change. You can use the value, no problem. No, you can use the value. Okay. Should we draw the enthalpy? Yes. You have to draw the enthalpy. Yes. Okay. Can you use enthalpy change or just write the type of enthalpy change? You can use value. Yes, you can. So in our case in here, can I? Okay. Wait. This one you use 1/8 as 8 is better lah. Sorry. One over 8 as 8. This one you write 1 over, because the question used 1/8 as 8, right? So you use 1/8 as 8 also. Yes, better. Okay, you can use the value or value. Okay, or value. Both of them are accepted. Is it over? Okay, can, no problem. Energy cycle means Born-Haber cycle. Born-Haber cycle is specifically used for the lattice energy. So usually they are the same. Yes. There was a year 2019 or 2020. They said energy cycle, but it's actually Born-Haber cycle. Okay. So is it fine if yeah. Actually, electron not written in the this one also can, no problem. Can. This one is out of habit. Mr. Chu habitually write electron inside the cycle. Why I purposely put inside the electron inside the cycle is to show you the balance of the whole cycle. So even if you don't write the electron, is also okay. So we define we should put the related equation in the enthalpy change. Not sure about this. Can you please be more specific? Sorry for that. How many marks for the diagram? No, usually 4 to 6 marks. In this case, 5 marks. In this case, 5 marks. Usually 4 to 6 marks. In this case, 5 marks. If the stated value need to state unit or not, no need. No need to state kilojoule per mole because your y-axis already put there kilojoule. So no need to state. Just write the value is enough already. Usually Born-Haber cycle is very, very high marks. So that is why students, when they see Born-Haber cycle, they are very exciting because usually they can give a lot of marks in here. Okay. Yes, can we combine first and second ionization energy? Can, no problem. You can combine, no problem. Yes. Okay, so can okay, so now how to calculate the value of the this one? So when you sum up, so negative 2612 plus positive 89 plus positive 492 plus positive 1080 plus positive 555, you get negative 396 kilojoule per mole. Okay, so it's a very direct answer. So I hope that you'll be able to this one. Okay. Okay, so that is for number A. Okay, 1. And then number 2, estimate the value. So when the question asks you to say estimate or predict the lattice energy, so try not to use the word higher than, lower than. No, just give a value. Just give a value. Okay. In here, kilojoule. Don't put kilojoule per mole. Just put kilojoule enough already. Okay, so lattice energy of calcium sulfide, let's say negative 3000. Any value higher than 2612 is good. Any value higher than 2612 is good. Even you put 2617 also we consider correct, as long as it is higher than RAS. Okay. Okay, why? Because the lattice energy is directly proportional to the charge, yet inversely proportional to the inter-ionic radius, or you write equation form also can. So as ionic radius of the calcium 2 plus has the same charge, yet smaller ionic radius than Ra plus, hence the lattice energy of the calcium sulfide is more stable or it's more exothermic than radium sulfide. So keyword in here is the ionic radius of the calcium is smaller, yet the charge is the same. Okay. Can 5,000 can, no problem. 5,000 can. Any value higher than 3,000. The keyword in here is estimate a value or predict a value. Don't say higher than, lower than. No. Okay, don't use that higher than, lower than. So any value are accepted as long as they are more exothermic than negative 2612. They are all accepted. Okay. Okay, any else? Okay, so that is for number 1 and number 2. Okay, then we go to number C. Sulfur exists as an acid molecule in solid state. Use the data in this question to calculate the enthalpy change of the reaction. S8 solid give 8S. No, cannot. You don't. Can we say that cannot? No, don't put like this. This is totally different thing. Charge density is different thing in here. Yes, can, no problem. Can, we can use symbol, no problem. Please don't write like this. Please don't write like this charge density. They are totally two different things. Okay. Okay, so how do you calculate this? So 1 over 8 S8 plus 3 minus give S2 to S2 minus delta H is positive 555. That is what given in the question. Also in the question, you are also involving, this reaction involve a few state enthalpy changes. 1 over 8 S8 give S gas. So this is what you want to find first. And then you are given S, the first electron affinity, S gas plus E minus give S minus. and then S minus gas plus E minus give S2 minus. So you reverse the second and third equation. So you get 1 over 8 S8 plus 2E minus give S2 minus. So S gas give S plus and then S2 minus like this. So at the end, you can start to cancel in between things. So what can you cancel in between? Okay, so you can, okay, so what you can cancel, you cancel 2 electron with 2 electron in here. You cancel S2 with S2. Then you cancel S minus with S minus. Do you see that? So at the end, you have 1 over 8 S8 to S solid in here. Okay, so your enthalpy change is the summation. So positive 223 kilojoule per mole. But look at the question. The question asks for S8 give 8S. So as a result, you have to multiply by 8. So your answer is 1784 kilojoule. Okay? So that is how you are going to answer for these questions in here. Okay, so that is for 18C. So any questions that you want to ask in regards to chapter 1 of this? May I ask, when we use bond energy or atomization, sometimes the question don't give the value of atomization but bond energy. What value is multiplied by half? It depends on the situations. Like for example, if let's say they give you magnesium, they want you to find for magnesium chloride, isn't it? Let's say MgCl2 okay? You give MgCl2 correct or not? So if let's say they give you MgCl2, so this one, if they give you in the form of bond energy, so bond energy straight away use the bond energy in here, okay? But let's say if they give you the enthalpy change of the atomization, so enthalpy change of atomization in here is times 2 . So what is the difference in between these two? Because in bond energy, it is chlorine, you break the covalent bond to become 2Cl, correct? Where this is bond energy. Okay? And then for enthalpy change of the atomization, so you have a half Cl2 give 1 Cl. Okay, so this is the difference in between them. Okay. Okay. Do we need to change the significant figure for the final answer? No need, no need. For this case, no need. When I asked if the cell diagram is different phase, should we put a comma or one line? One line. Solid, liquid, gas are all in one line. There is an argument of aqueous and liquid. Aqueous and liquid we consider as the same state of matter, especially when it involves water. So same state, then we put comma. Okay. But if solid and gas, then they are totally different state of matter, then you cannot. Okay. Can? Okay, so that is for question number 18. Okay. Okay, shall we move on to the next one? Okay, number 19. Beryllium hydroxide possess different physical and chemical properties compared to other group 2 hydroxides, such as solubility, acid-base properties, and thermal decomposition. By describing the solubility of the beryllium hydroxide, magnesium hydroxide, and barium hydroxide, estimate the pH value of this hydroxide. Okay. Okay, Enoch, can you reserve this question when we have the Q&A session later? Can we reserve this question? Okay. I reserve your question later. I'll come back to you. Don't worry. Okay. Okay. So by describing the solubility of the beryllium hydroxide, magnesium hydroxide, and barium hydroxide, estimate the pH value. So in here, you should say that beryllium hydroxide is sparingly soluble in water, hence does not show any value in the pH indicator, or it does not give any pH value. Okay. Whereas magnesium hydroxide is a weak base in water because it is sparingly soluble in water. Okay. So the pH is, when they said estimate a value, any value in between 8 to 10 are acceptable. Okay. And then barium hydroxide is a strong base in water, so the pH value is somewhere between 12 to 14. Okay, so just estimate the value inside there. Okay. Okay, so each of these statement is 1 mark for each of them. Okay, so that is for number A. Very straightforward questions. Okay, B. Using hydrochloric acid and sodium hydroxide, describe the acid-base properties of barium hydroxide and barium hydroxide. So you should say that barium hydroxide is an amphoteric compound. So of course you have to write using HCl and NaOH as the equations. So state of matter is a must. Okay, try your best to write the state of matter. All right. Okay, 3 marks already. And then barium hydroxide is basic, 1 mark. Okay, or the equation. Okay, either this one or equation. But you must state that barium hydroxide is basic, of course. Okay. Okay, so this one 4 marks only. Yeah. Either you must mention that barium hydroxide is basic compound, right? And then write the equation based on that. Okay, so that is for number B. Okay, and then C, compare and explain the thermal decomposition between beryllium hydroxide and barium hydroxide. So how are you going to answer this? So if you can, try your best to explain based on all these points in here. You must have barium hydroxide is thermally less stable than barium hydroxide, 1 mark. And then definitely you have to write the decomposition equation. Barium hydroxide solid give barium oxide solid plus 2H2O, 1 mark. And then barium 2 plus has a smaller ionic radius than barium ion, 1 mark. Therefore, barium 2 plus has a higher charge density than barium 2 plus, 1 mark. Barium 2 plus has a higher polarizing power than barium 2 plus, 1 marks in here. Then you should be able to also to mention barium 2 plus easily distorted the electron cloud of the OH minus, hence weakening the OH bond and decompose. Okay, so these are the 6 important points that you must try your best to write whenever you're trying to describe the thermal stability. So I hope that because this question long time didn't come out already, so you might want to have a mental preparations to explain this. So this kind of explanation is the same to this no matter you're talking about this nitrate, hydroxide, or carbonate, you use the same factor to describe. Okay, so that is for number C. Okay, any questions for question number 19? Or any question related to chapter 4? Okay, so hopefully no problem. If no problem, then we goes to the next one, Ken. Okay, so the final essay question asks about group 17. Describe the reaction of the each halide ion with aqueous silver nitrate followed by ammonia, dilute or concentrated. Okay, so in this case, you can put a table form to make your life easier. Include also observation is possible because the question asks you to describe. Okay, so you should also put in the observations in here. So when react with silver nitrate, silver chloride form white precipitate of AgCl. Silver when react with bromide ion, you form silver bromide, which is a cream precipitate. And silver ion react with iodide ion to form silver iodide, which is a yellow precipitate. Okay. So for silver chloride can dissolve in both concentrated and dilute ammonia aqueous solution. According to the equation, AgCl plus 2NH3 give AgNH3 2Cl plus and Cl minus. Whereas sodium bromide can only dissolve in concentrated ammonia but not the dilute ammonia. So according to the equation, AgBr plus 2NH3 give AgNH3 2 plus Br minus. And finally, for iodide, Yes, you can draw a table, no problem. You can draw a table. Okay. Whereas for silver iodide, it is insoluble in both NH3, no matter it is concentrated or dilute. Okay. Okay. So that is for the iodide for A lah. Okay. Okay. So that is for A. Okay. Now B. To fix photographic print, unreacted silver bromide on the paper is dissolved in aqueous sodium thiosulfate, Na2S2O3 aqueous. So aqueous sodium thiosulfate was dissolved in silver chloride and silver iodide. Using this information and your answer in 20A, predict the relative strength as the ligand and as ligand of thiosulfate, water, and ammonia. So give your reasoning in here. So you have to mention the relative strength of the ligand in the order or is S2O3 2 minus and H3 then H2O. I know actually this is directly taken from past year A-level questions. I directly take from there. I'm so sorry. That I used in here. So you have to mention that water is a weaker ligand than concentrated Cl minus and also ammonia. Ammonia is strong enough to displace Cl minus but cannot displace I minus. Then the S2O3 2 minus is stronger ligand because if it is a bidentate ligand, okay, in here, okay. So some of you can are confusing on teacher, how does S2O3 2 minus looks like? So I'm going to draw for you how S2O3 2 minus looks like. For your information, this is how S2O3 2 minus looks like. You have a double bond O. You have a double bond O. You have a single bond O like this. And then S like this. So that's why we say that it is a bidentate ligand, because you can use the -1 to use to the attract to the center metal ion. Okay. Should we need to memorize the ligand strength? Replace, substitute also can, no problem. Should we memorize the strength of the ligand? Remember a little bit lah. Remember a little bit lah. Remember a little bit. Okay. Yeah. Okay. Thank you very much, Mr. Go, for helping me to explain to the students also. Okay. So that is how you are going to answer B. I'm not, to be honest, I just take from the past year A-level questions and ask you all. I'm so sorry lah. Okay. Okay. And last but not least is C. Why is the addition of chlorine in drinking water is important? In here, I put wrongly the distribution of marks. Supposedly, this is 2 and this is 3. I put the marks wrongly distributed. This is 2 and this is 3. Okay, so I wrongly placed in here. So now, why is the addition of chlorine in drinking water important? So you have to write the equation of Cl2 plus H2O give HCl plus HOCl, or you say chlorine dissolved in water to give HCl and HOCl. So the oxidizing action of the HClO kills the bacteria in drinking water, whereas the Cl2 acts as a disinfectant when adding to the drinking water. So that is how you are going to explain why is it that chlorine is this one. There is 1 year that asks why fluorine cannot be used instead of chlorine, but because fluorine is a very strong oxidizing agent, so not suitable. Very strong oxidizing agent and hence toxic to the water. So that is why it cannot be used as this one. Okay. Okay, last but not least, number 2, with the aid of equation, ionic or otherwise, explain why the smell of chlorine disappear when aqueous sodium chloride aqueous chlorine is made alkaline. So you write the equation, Cl2 plus 2OH minus gives Cl minus plus ClO minus plus H2O. So you have to answer that in alkaline medium, chlorine undergoes disproportionation to give Cl minus or ClO minus. Hence, the smell of the chlorine disappear due to neutralization. Okay, due to neutralizations. Okay. So that is why the smell disappear. Okay. Okay, so with that, I hope that I helps you a little bit on understanding better on how to answer semester 2. Okay, so so then we have a Q&A session right now. Okay, so you can ask any question. Okay, I'm going back to what Enoch asked me just now. Sir, if N2 is triple bond, the bond energy given to break all triple bond or only one bond? Definitely all triple bond. Definitely all triple bond. That is why there is this question that asks this if this what nitrogen, why does the reaction involving nitrogen usually has high enthalpy change? So you should say that nitrogen has a short and strong triple bond with high bond energy. Okay. Okay. HCl and HOCl can be used or not? Yes, yes, yes. Both same. In STPM context, so far we still consider the same. Okay, but it's actually HOCl lah. It's actually HOCl. Okay, so I'm going to give you a few more minutes for you to ask any questions to you if you want to. Sir, if acidity strength of the group element, what are the key points in here? If you are saying about HX, HX in here, so the acidity increase from HF to HCl to HBl to HI. So you are going to say that HF is a strong acid. HF is a strong, weak acid due to the strong hydrogen bond. HCl, HBl, HI acidity increase. So this has something to do with atomic radius increase, bond length increase, bond strength decrease. Okay. So if you want to explain about acidity of this one, you use atomic radius, bond length, bond strength. So that is the best to explain. Okay. Okay, so next one, teacher, how about HClO3? You won't form HClO3. You won't form that. You won't form that. Huh? Okay, sir. In cell diagram, we won't write H2O if half equation. Yes, usually we don't unless that H2O is the reactant. Unless H2O is reactant. If H2O is the reactant, yes, we write inside there. So if don't show pH value, can like answer 18. Question already asked you to estimate, isn't it? I believe that the question asked you to estimate the pH value. So you must write certain pH value. Complex ion color must memorize. My advice is copper. Copper, try your best to memorize copper. Try your best to memorize iron. Copper, iron, among the two most common ions the STPM often love to ask. So does beryllium react with water? Beryllium cannot react with water. Cannot. Because of the impervious oxide layer. Does acidity and reactivity of HX the same thing? No. Acidity is talking about how much is the concentration of the H3O plus in aqueous solution. It has nothing to do with the reactivity. So totally two different things. So these are two different things. So if advisable, write essay but no point form here means point form is sentence also not encouraged. Yes, try to avoid that. Try to avoid writing point form. If possible, write in essay lah. Okay. So its energy level diagram and Born-Haber cycle are the same. Born-Haber cycle, as I mentioned just now, is specifically to describe the T's energy. Energy level diagram. Born-Haber cycle is part of the energy level diagram. Okay. So for estimate pH value, is just right pH of magnesium oxide is okay, can, as long as the value become higher. Okay. No, wait. For barium hydroxide, it must be strong base value. it must be somewhere between 12 to 14. Then for magnesium hydroxide, it's somewhere between 8 to 10 or 12 like that. There is a certain pH for that. There is a certain pH for that. So how to distinguish to use atomic radius and cationic radius? Now, if you notice, if you remember, we only use cationic radius when it involves ionic compound. Ionic compound, we use cationic radius. If it is involving covalent compound, usually we use atomic radius. Okay, like for example, you want to discuss about the group two thermal decomposition, isn't it? You see, we use cationic radius, right? But if we were to discuss, let's say, for example, thermal stability of the CCl4 or MCl4, or we use the thermal stability of the HX, or we want to describe boiling point of the group 14. So we often use the atomic radius, right? Because they are all covalent compound, okay? So it's 3D subshell, same with 3D orbitals. Usually we use 3D subshell in certain cases. But they are actually the same, yes. So if magnesium react with water to form magnesium oxide or magnesium hydroxide, magnesium react with steam to form magnesium oxide. Magnesium is sparingly or insoluble? Sparingly. So if Hess cycle, same with the energy diagram. As I already answered just now, Hess cycle is part of the energy level diagram. So when we are counting for E cell value, we don't need to change the value, right? If you use E cathode, if you use E naught cell equals to E cathode minus E anode, don't reverse the value in the standard electrode potential. Okay, don't reverse the standard electrode potential there. Okay. So beryllium and barium hydroxide are both amphoteric. Beryllium can react with concentrated alkali, while other group 2 cannot. Barium oxide is amphoteric, yes. Does GO has giant covalent? I think so. GO, I think is giant covalent. Can you try to Google a little bit? I think GO, if I'm not mistaken, I didn't memorize wrongly, GO2 is giant covalent. Okay. All group 70s must use molecular radius. No such thing as molecular radius. Don't use that. Either you use atomic or ionic radius. There's no such thing as molecular radius. Molecular size, yes. Okay. Do we have to memorize the color of complex ion? As I already mentioned just now, try your best to remember for iron and copper. These are the two most common. Okay. So its WHO solution is exo and endo. It can be exo, can be endo. Exo is indicating that the salt is soluble in water. Endo is indicating that the salt is sparingly soluble in water. Can compare NaCl with AgCl with electronegativity. This one is used when you are trying to describe the what. Why is it that there are few years that ask about this kind of question, but generally the reactions are they want to ask about NaCl and AgCl is in the form of the why is it that the experimental value and the theoretical value of the lattice energy in between NaCl and AgCl has such different. What do I mean here is theoretical value and experimental value of NaCl is almost the same, but theoretical value and experimental value of AgCl is very far different due to the difference of electronegativity. So you use that angles to this one. This was asked in STPM 2013 SEM 2 Ulangan, 2017 SEM 2 Ulangan, and 2018 if I'm not mistaken. So you can check back on this one. Okay, thank you, Mr. Goh, for helping me to react. Okay, so if I couldn't remember certain equation, especially essay, does it mean that there is less chance to get full mark? I don't expect, as I told you, Afiq, as I told you also many times already, we don't expect students to get full marks. Okay, just do your best to score as many marks as you can. For me, there are only very little students who can get full marks, unless the essay question is very easy. So just do your best. Afiq, don't worry too much. So if possible, try your best to remember as much as you can. If cannot, then never mind, forget about it. You did your best. I know there's a lot of things to memorize, but what to do? Okay, so do we need to memorize all silicon sheet? If silicate, try your best to remember only single chain silicate, double chain pyroxene, amphibole, and the silicate sheets. That three enough already. The rest no need to memorize. This Nernst equation, sometimes question will give you, but it's 0.059. Sometimes question will give you is 0.05. Also, Nernst equation, try your best to memorize. This one also very important. What are the points explaining the structure of complex ions? I do not quite get you. Can you give me an example? So in equation, if I write strong state of matter wrong, that's why I said okay, if thermochemical equation, they are very specific. Thermochemical equation, they are very specific. Yes, it's wrong. If you write wrong, then it's wrong. Okay. For this one, can you give me specific questions so that I can discuss? Okay, thank you very much, Mr. Go, helping me. Okay, any else? Okay, so for semester 2, all I can say is just there are a lot of things to memorize. I'm so sorry. You really have to work out on your own somehow in memorizing all these points in here. But all I can say is you should do your very best. Okay. Teacher, explain the formation of CuCl4H2O. In the 2018 question number 20. Okay, wait. Okay, can I stop? Okay. Wait, can I wait? Wait. 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 Sorry. Give me 1 minute. I find for you. Wait. Sorry. Okay. I think you are referring to this, right? Okay, so just do your very best to name and then say that chlorine and water act as a monodentate ligand, which is stably bonded to the copper using dative bond to form octahedral complex and to form yellow color solutions. So it's very, that's why I said when it comes to this group 17, it is actually very difficult. Very, very difficult. Okay, very, very difficult. Okay, teacher, thermal stability can explain with inert pair effect. Nothing to do with inert pair effect, my dear. No, 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 no. So can you explain inert pair effect? Inert pair effect is due to this one. Wait, okay, stop screen, present, share screen, this one, okay. Okay, so this is what explains the inert pair effect in here. Inert pair effect is due to, you see from the slide in here that I share, 6S and 6P, they are blocked by 4F and 5D, isn't it? So, the electrons hard to excite from the 6S to 6P, so therefore remain inert inside the 6S here. So that is what we mean by inert pair effect. Okay. Okay, so it's not stated dilute concentrated Cl2 will change charge at anode electrolysis. Actually, in here, usually it's like that. When we say our, actually, the definition that you use for standard or dilute, in your SPM level, in most of your knowledges, you feel that dilute HCl, dilute NaOH, HCl, the concentration is lower than 0.01. But in STPM, when we say dilute, it's already standard 1.0 mole per decimeter cube. So that's why if you want to the Cl minus to be more selective, that is why we use concentrated in most of our case. So in short, I'm ready to say like this. In the electrolysis involving halide ion, Cl minus, Br minus, I minus, they are definitely going to be selected in the anode. Okay, they are going to be selected in the anode. The Cl minus is selected due to over voltage effect. So what is over voltage effect? You have to Google a little bit to find out what is over voltage effect. Okay. How to explain thermal stability of group 14 monoxide and dioxide? This one. Wait, wait, sorry, this one. Okay, so this is the best that I can share with you, how to explain that. Okay, so you screenshot and then you have a look later. Okay, sir, in exam, is it better to do subjects? Time management is important. Usually, usually it's like that subjective essay prioritize first and then do the objective last one. Okay, usually it's like that. Usually, sir, is silicate sheet and silicate doesn't matter doesn't really matter doesn't really matter. They don't really bother about silicate sheet or sheet silicate. They don't really bother. Is the reaction of H2Br2 reversible? No, irreversible. Irreversible. Only HI is reversible, yes. H2 and Br2 will occur only at 200 degrees Celsius, very at high temperature, and once HBr is formed, it's hard to dissociate. That's why it's irreversible. Only HI is reversible, okay? Okay, Ken? Okay, so I guess that is all for our sharing session for today. So all I can say is good luck to you in your semester 2 examination next week. Okay, so keep studying and do all the best. And I hope that I'll see you all in semester 3 in the next sharing session. Okay, okay, welcome. So hopefully you all will benefit at least even a little bit lah. So that is the best that I can do for you. If you want more, if you want to refer back to all of this, you can even look back at all the this live that I do in YouTube. So this one, okay. So okay. So with that, I end my sharing session for today. So good luck and have a good remaining school holiday lah. Okay. Okay. Bye. Welcome. Welcome. Yeah. So I end. Okay.